Hey Monica, here's another group of stuff that we can talk about. Some more parent functions. If I have the y equals the cube root of x, when x is positive, when x is 8, y is 2. When x is 1,000, y is 10. It's going up. It's not going up very fast. And likewise, when x is negative, when y is equal to negative 1,000, when x is equal to negative 1,000, y is equal to negative 10. So the graph of that function is going to be not very pretty, what I drew, but that's going to be that. Your book is also giving examples of like x equals, this is not really a function, they're calling it a function. I'll talk about that when I see you. X equals the square root of y. I mean the absolute value of y. We talked about y equals the absolute value of x. And that is this V-shaped thing that looks like that. When you flip it around, if you plugged in some values for x and y, you'd see that it's going to look like that. So that's when you do the table of figuring out, plugging in values of x, seeing what y would be for this function, and gradually developing the graph of it. Likewise, if I said x equals y squared, that's similar to y equals x squared, which looks like this, as we already talked about. But now, if you, again, do a table like this, you're going to see that the graph of x equals y squared is going to look like that. So you're flipping it around in a way. It's really not a function, and I'll talk about that with you when I see you. Then the only other thing that they're talking about in this section, and it's what the next section is about to a large extent, well, they're also doing piecewise functions, which you and I have dealt with, and you didn't seem to have any trouble with that. Piecewise functions do y equals x squared in the case where x is greater than 3. Y equals negative 2x. I'm going to try to make this work. Plus, well, it's not working really. It's in a particular case. So as you and I talked about, these are kind of passing the torch. I've got a function with this one here is a linear function. It's got a negative slope and a positive y-intercept up until when x equals 3. So it's going to do something like this. In this case, they pass the torch kind of evenly, because when x equals 3, this is equal to 9, and when x equals 3, this is equal to 9. So it's continuous. It doesn't have to go like that. I can have piecewise functions where it goes like this. The first function stops when x is less than 1, say. And then the second one picks up when x equals 1 and starts doing that. Typically, they may not be continuous. I had to pick up my pencil when I got down here and lift it to go up to here. But that's a piecewise function. I think you demonstrated to me that you understand the way that goes. Then the last thing I'm going to talk about in this video is, what do they call it? They call it the greatest integer function. It doesn't, you're not going to see it a lot as you get further in math. They use these brackets around x. Again, this is a parent function. And it would be the type of thing where you get paid $5 for every cookie that you bake. But if you only had a chance to bake half a cookie, you don't get paid for that half a cookie. So what happens is you get paid 0 up until when you make a full cookie. Then you get paid for a cookie up until you make your second cookie. Boy, what an example. And then once you get to your third cookie, you get paid for that. You don't get paid anything until you've completed your fourth cookie. Crazy things that I talk about. And so that's the greatest integer function. And that's also what I think is the next section is on this. They may go into weirder details of this. Like I say, it's not the most important thing in the world, and you're not going to see it all that much as you go further into math. But that's the greatest integer function. Monica, I'll talk to you tomorrow one way or the other. But I think that's enough to help you get through the next section. And communicate with me one way or the other, and we'll get done with the next section, and then we'll start working on the following one. And we'll rip through all this junk. Okay, have a good evening. Bye.